Is it recording? What's up, bros? Today we're going to talk about spermatogenesis. Spermatogenesis. Let me wear my glove. So, what is spermatogenesis? You remember I talked about folliculogenesis, but I didn't talk about oogenesis. But it's somehow related, right? So, that time I didn't say how the oogonium comes, but I have to talk about it this time. So oogonium is made from the primordial germ cells. Those primordial germ cells are formed from the yolk sac that has relationship with the embryonic development. What I mean by the yolk sac, that's the yolk sac, right? It comes from there, and then in week 5 and 6 says, "Fuck this shit! I don't want to stay here. I'ma get out of here. I cannot stay around here for all my life. I need some sort of adventure." So it goes through the connective stalk and colonizes the gonadal ridges or genital ridges, gonadal streaks, whatever. Right? He says, "I love this place, but I have to throw away my remnants. I don't want to be called primordial germ cells. After I colonize this place, my name is now Spermatogonium. Yeah. Or Spermatogonia for multiple cells. Yeah. No, he's badass. He's rebelling. Oh, shit. No. Yeah. So they remain there. Says, "Yeah, I want to chill here for a while till puberty. Nothing else can happen. Even if something else happens, it's futile. There's no use of it because shit." Okay, there's no use of such thing because where the hell is that picture? Where the hell? I don't know. I didn't most likely add the picture. Wait a minute. Do I have it there? No, I didn't add it. Yeah, whatever. Because the seminiferous tubule is cored. It's not hollowed yet. There's no that space because it's filled. So there's no point of doing anything. Well, when you reach puberty, that cord is. The seminiferous tubules gets hollowed. Let's say it goes through a process of canalization. Yeah, right. Then that's most likely due to testosterone. Then what I know about this, what the hell testosterone do with us today is testosterone says, "Yo, Spermatogonia, you have to do a lot of stuff. You have to do some shit, man. You've been chilling here for years, bro. What the hell?" So the Spermatogonia, they lie at the periphery of the seminiferous tubules, adjacent to the basement membrane. Okay, they are surrounded by sustentacular cells. These supportive Sertoli cells, right? But before that, they undergo the process of mitosis, and let me come back to the writings. They undergo the process of mitosis and form type A spermatogonium and type B spermatogonium. Type A spermatogonium, these essentially provide you with a lifetime worth of stem cells of spermatogonium. So when the spermatogonium divides into this type A and type B, type A goes back spermatogonium, type A, type B. Type A says, "Nah, I still think that I want to chill for more. I'm not an adventurous person." No. And goes back and provides a stem cell for another thing, right? Then B says, "Hell no, I'm done with that shit, man. This is boring. I need some sort of adventure." Again. So, but he cannot do anything yet. because it will undergo meiosis. And the products of meiosis are genetically different because they have less chromosomes, half of the set. So I brought this picture. This is a full set of chromosomes, 23 pairs or 26 chromosomes. So those who undergo meiosis will have half of that, right? So they're genetically different, and the immune system says, you guys are not like us. You guys are foreign. We're gonna take you out. Yeah, and you have autoimmune problems. Fuck. So before that, they have to go through the cystenticular cells, because between the cystenticular cells, these cells are gap junctions. Gap junctions, tight junctions, you name it. So what happens is that this is our, say, type B spermatogonium, and these are our two cystenticular cells that are adjacent to each other. So what happens is this guy goes there, this guy goes there, the tight junction between them disintegrates, this guy goes through them, and both of these come back together and close the tight junction behind this, the spermatogonium. Once the spermatogonium, type B spermatogonium, is separated from the immune cells, it crosses the blood. It's called blood testis barrier, but I call it blood balls barrier. Yeah, it's more funny. You can remember that. So once it passes it, it's now called primary spermatocytes. Let's go back. Fuck. Shit. My pencil is out of... God dang it. My pencil is out of battery. Shit. How do I disconnect from pencil? Oh, yeah. Where were I? It passes it, and it's now essentially called primary spermatocytes. Let's say this over here is called primary spermatocyte. For example, right? It enlarges, it prepares itself for meiosis 1. Then it undergoes meiosis 1. What the hell am I doing around here? I didn't go through that blood balls barrier to stay around. No. I enlarge and I divide, and now it went through meiosis 1, and now it's called secondary spermatocytes, and it's not going to stay around there for too long. It says, hell no, I ain't going to stay around here for too long. I want some adventure. Yeah, adventure. These cells are adventurous cells, right? So they undergo meiosis 2. Now they are called spermatids. The spermatids won't divide anymore, because meiosis is just meiosis 1, meiosis 2. It's 2 times, not 3 times. So instead of that, they undergo transformation, which is called spermiogenesis. So they discard most of the cytoplasm, and they get a tail out. They discard most of the cytoplasm. If you remember that I talked about in the first video, like I made a lot of videos, shit, right? That one has to be motile and light, and the other has to have ample of nutrients and be heavy and immotile. The heavy immotile females have those because their belly gets bigger. But now we want the motility is on us, so discard most of the cytoplasm, get a tail out to be mobile, but they won't move until they get ejaculated outside of our body. So yeah, it's for later on. And form the spermatozoon. Even though, like, that I wanted to talk about it, like the title says today, but nah, for another day. I won't prolong this, and I don't want to read that again. Yeah. So one thing that I want to add is, like this picture denotes, it's somewhat. See those projections? Those are cytoplasmic projections. We have a picture over here. Those are cytoplasmic projections. Between the immature sperm, they have cytoplasmic bridges between them, but once they mature enough, they get separated. They be like, I don't want to work with you guys. You guys are slow. I'm fast. I want to fertilize. I want to fuck the egg. I want to fertilize the egg. And you guys, I don't want to work with you. No. Then the sperm next to him, shut the fuck up. You're slow. You're the one slowing us down. You're the one who's being behind. Through all the process of meiosis, through all of those times that we've been together. That's that. Let me talk about another thing that let's for example divide this cystenticular cells to multiple levels. Like that. Let's say this is level 1, 2, shit. Where is it? Yeah. Level 2, 3, 4. For example, I don't know how many levels are there, but this is for the sake of the demonstration. The more progressive they be in the process of meiosis, the sperm, let's say the sperm, right? The more closer they be to the lumen. See? 4, 3. These are more progressed than these two, right? That's that. And the spermatogenesis happens in a cycle-like manner, wave-like manner. That's why they call it spermatogenic waves, because at certain particular level in the spermatogonium, there are numerous cells at the same stage. But the cells are, let's say, randomly distributed. For example, number of cells are at stage 3. Another number are at stage 2, like that. That's why this process of sperm formation is continuous. By each minute you form 400,000, but by a day you form 400 million. With each heartbeat is 400,000. Let me check that. A young man produces about 300,000 sperm per minute, yeah, and 400 million per day, and 4,000 million per 10 days. Right, that's that. It's actually that. There's nothing else to add to it. So let me check if I have left anything. Is that cells of one stage bound to each other by several bridges, blah blah blah. Done that. Yep. And that was it for spermatogenesis. I will talk about spermatozoan. I have to talk about spermatozoan. Still, I haven't talked about the anatomy of the female and male reproductive system, which I have to talk about that. I haven't talked about the oogonia, which I have to talk about that. And many different other processes. Topics. I have to talk about meiosis as well, but that topic is pretty long. For now, peace!